Okay, SP3 energy transfers including A and B. So energy transfers and energy efficiency. Okay? Very quickly, the equations from the whole of SP3, topic 3 on energy, all the equations that you will be given in this chapter that you actually have to remember and you won't be given at the back of the exam. So efficiency is the Greek symbol epsilon. E equals useful energy divided by total. Okay? You may be given that as a decimal, or you may be given it as a percentage. Now, if you want to convert to a percentage, you just have to times by 100 at the end. If they do give it you as a percentage, and you have to use it in the equation, you need to turn your percentage into a decimal yourself. Okay? Just divide by 100. Alright? If they ask for efficiency and they say in the answer percentage, then you just have to multiply it. If it's a decimal, then it's fine. Okay? No units for efficiency. Okay? Maximum efficiency of any appliance or any machine is 1 or 100%, but nothing that we know of in real life, okay, can achieve 100% efficiency. Alright, we'll look at why in a second. GPE, or gravitational potential energy, which is the energy stored in an object due to the fact that it is above the surface of the Earth. Okay, so due to the fact that gravity is acting on it and it's pulling it towards the surface or center of the Earth, then it has that potential energy stored. If it's allowed to be transferred, then it will obviously be used to move towards the center of the Earth. Kinetic energy, generally the transfer that goes from GP, gravitational potential, is kinetic energy. So if something is above the Earth, it tends to want to move towards. So kinetic energy is the movement energy of an object stored in the object. 1/2 mass times velocity squared. So kinetic energy of an object is 1/2 mv squared. Only square the velocity or speed. Do not square the whole thing. Okay? So make sure you don't make a mistake. And we're going to also put work done back into this equation. This came up first in braking distance in chapter 1-2. Okay? Where the brakes on a car became hot and it slowed it down. So car was moving, had kinetic energy stored inside. Brakes applied a force. The car travelled a specific distance, came to a stop. The energy transferred from kinetic to the car stopping, hence the energy had transferred to the surroundings as thermal energy. That was the work done by the brakes. That was the energy transferred. Okay, so work done equals force times distance. The force in the same direction the object travels. Okay, so in the same direction as the distance. All right. In fact, first we're going to look at the conservation. So the law of conservation of energy, which essentially is the foundation of this whole chapter on energy transfers. The law of conservation is energy cannot be created or destroyed. It can only be transferred from one form to another. Okay? The only time energy was created, we know, is from the Big Bang, as the theory goes. Okay? So any energy that was created, what we believe at the minute, at the start, is the energy we have now. It has just been changed over time. It's evolved. It hasn't been, no more has been added, none has been lost. Some is wasted continuously, but it's still transformed into different types. That's the law of conservation of energy. Cannot be created or destroyed, but can be transferred. Stores of different types of energy are thermal. Okay, we know thermal energy obviously is heat energy. Okay, or thermal energy stored. GPE is gravitational potential. We just learned is according to the mass of the object, the gravitational field strength, the height above the surface of the Earth or object. Chemical energy stored in an object. Kinetic, which is the movement of an object. Elastic potential energy, or EPE, which is energy stored in a stretched or compressed object, springs, elastic bands, for example. Nuclear energy, which is actually stored in the nucleus of different elements and atoms, okay, mainly used in the sun. So in the center of the sun, nuclear fusion, that's the nuclear energy stored, being transferred into other forms that we actually use, okay? There are 4 ways that those stores of energy can be transferred. So you can have a store of kinetic energy if an object is moving, but if you want to transfer that to a different type, it has to be transferred by something, okay? Light is one way that energy can be transferred from one place to another or one form to another. Electricity can transfer our energy from one form and place to another. Heating, so if energy is transferred, lost to the surroundings, stored as thermal energy in the surroundings, that will have been transferred by heating. Okay? And finally, force. You can transfer energy by force. Very commonly, sound, which is known as a type of energy, which is transferred from one place to another, can also be said to be transferred by forces between the particles that are vibrating and therefore passing that energy along. Okay? So moving on, if we have all the types of energy stored and the way that they can be transferred, we may be required to draw an energy transfer diagram, or just ask simply, what are the energy transfers in this situation? Most commonly, a car that's driving along a road that brakes to stop. If it has kinetic energy when it's driving, according to its mass and its speed, and then it brakes and stops, that kinetic energy can't just have disappeared. It had to go somewhere, had to be transferred by something to something. So, kinetic energy in the car when it's moving. If you want to stop your car, you apply the brakes. That means you have to put a force on the pedal, the brakes have to apply a force on the wheels, so the transfer in the box, if you want to draw an energy transfer diagram, it's in a box for the stored energy, kinetic, transferred by is the arrow. So if I'm driving with kinetic energy, I press my brakes, I apply a force, that's transferred by forces. Stored as thermal energy in the brakes. The brakes begin to glow red. They are increasing the amount of thermal energy that they have inside them because the car is losing kinetic. So any loss in kinetic will be a gain in thermal. Okay? If the thermal energy is stored in the brakes, obviously, inevitably, the car will stop. All the kinetic is now all the thermal, but the thermal energy in those brakes will actually be then transferred by heating to a new thermal store in the surroundings. Okay? So, it will probably not just sit there in the brakes, it will actually be dissipated to the surroundings. Essentially, if thermal energy is transferred, we often say it's dissipated into the surroundings. It increases the thermal energy in the surroundings themselves. It should raise the temperature of those surroundings. For example, if kinetic energy was lost inside this, or wasted inside the lab, it has to go somewhere. If it's dissipated into the surroundings, technically it should raise the temperature in the lab. But because the lab is so big, it's going to be distributed widely. It won't have that much of an effect on the temperature, so you probably won't feel it and certainly not see it. Okay? But technically it had to increase the temperature because it had to go somewhere. Okay? Efficiency, very specifically, is an equation. It's useful energy out over the total energy that went in, or it could be the useful power out divided by total power. So actually efficiency can be said it's useful energy over total energy, or it's useful power over total power. Okay? No units, as we said before. This just basically means how much of all the energy that I put into a system am I actually getting out as useful energy? Anything that's not used for useful forms must have been wasted. Very often that will be heating to the surroundings, thermal energy. Almost every single machine, every process that transfers energy from one place to another, there will be some wasted energy due to heating and that thermal energy that gets dissipated. It's almost impossible to make a 100% efficient machine or system that doesn't transfer some energy by heating. 9 times out of 10, that heating effect will occur because there has to be something moving, therefore some friction between the parts in a machine. Okay? Often objects use sound as well as wasted forms of energy. If you can hear, for example, a car driving past, the sound from a car's engine is not useful. I don't need to hear the car, unless it presses its horn, but that energy is wasted. But the majority of wasted energy generally is thermal and by heating. Okay?